Last presentation for track 2, we will now proceed with our next presentation, VoIP Freaking Syphilis Unveiled. Before we proceed, let me first introduce our speaker for this talk. His handle is the Grug, and he goes by that handle. Grug is a domain expert consultant on VoIP security, digital forensic analysis, and reverse engineering. The Grug has spent 7 years working with all aspects of information security, from penetration testing to solutions and product development. The Grug's career has seen him working for financial security consulting companies, startups, and most recently, founding his own information security company. The Grug's information security expertise ranges from penetration testing and source code auditing through to rootkit technologies and advanced digital forensic analysis and investigation. Since 2001, the Grug has been involved in active voice-over IP security research, recently completing successful audits for major European and Asian telcos. So ladies and gentlemen, join me in welcoming the Grug.
Is this thing on? Okay, cool. Unfortunately, due to time constraints, I was not able to do the VoIP freaking attack. So what we're going to be doing is critical danger, an introduction to cross-site scripting attacks for people who do not know what cross-site scripting attacks are. Okay, so our danger is pretty straightforward. Whoa. An introduction to browsers, JavaScript. We're going to look at Java, the Indonesian spice trade, Dutch East India Company, scripts, movies, plays, and others. And then a brief look at browser attack visualizations, but unfortunately this is the text-only version. Okay, so now the real one. Okay, on VoIP freaking, this is the agenda that we've got lined up. Basically, we're going to have an introduction to VoIP and me, a quick abstract on VoIP. This is basically an overview of what VoIP is, the protocols involved, in theory, how it works. We're going to look a little bit at freaking, which is the historical sort of hacking prior to the internet, where people would break into phone systems and so on. Then we're going to look at VoIP freaking in particular, and then VoIP phishing, which is another sort of attack that will be coming out. It will be more prevalent in the year to come. And then we'll have a conclusion and a Q&A session. So, the introduction. Voice over IP is actually, VoIP is voice or video over Internet Protocol. The theory is it's basically just multimedia. So VoIP is hot. I am hotter. I've had lots of years of security research experience. I've been focusing on VoIP security since forever, and I've got a snazzy haircut. VoIP, on the other hand, has Skype, which is pretty lame in comparison. I think the important take-home message that you should, if you all want to leave now and go to the other side, what you should remember is this: VoIP is a serious security threat. Right? So this is because basically the deployments aren't waiting for security, and there are no secure practices that people are aware of. So basically everything's getting rolled out prior to people figuring out how to do proper rollouts, if that makes any sense. Right? So onto our VoIP abstract, where I'm going to teach everyone what VoIP actually is. So brief overview. A look at the functionality realms. VoIP is actually a generic term used to describe several different interlocking protocol suites, some of which are actually competing. Then we're going to look at those competing and complementary protocol suites a little bit more in depth. Then we're going to look at the infrastructure that's involved, and then we're going to look at some pictures. Okay. I've got a laser pointer. I'm going to use it, even though I don't have anything to point at. As you can see, this is a word that says provides. So the theory behind VoIP is it basically just provides a mechanism for people to communicate over a network. ever since networks started getting really popular and getting rolled out, all of these academics realized that there's an opportunity to do something other than send emails and text messages to each other. So they were working at ways to come out with multimedia over IP. And they started in the early 90s, and it took them years and years. Like, it's been a decade now since they published the first draft standards, and only now is VoIP really starting to sort of roll out and catch on. Part of the problem was that the early bandwidth just couldn't support the sort of space that these protocols take up. Right? When everyone's on dial-up, running something that takes 64K at a minimum is just not going to happen. On the other hand, given Thailand's internet, running something that takes 64K is not going to happen over DSL either. So, VoIP's popular in the first world. This is the thing, like basically, even though all of this stuff has been going on since forever, and VoIP is cool academically, and people get excited about security and all that stuff, the only thing that really matters is VoIP is a lot cheaper than telco lines, right? So cost is the major driver behind voice over IP. Everyone is desperate to save money. Even the telcos who are screaming about trying to shut voice over IP down on the ISPs, they are using VoIP for all of their backbone networks to save money as well. So, yeah, anyway, lying bastards. Functionality realm. So like VoIP, as we know, is now simply about multimedia over IP. How does it work? Well, there's basically 3 separate areas that you need to get working in an interlocking way in order to get VoIP to actually work as a system. So you need to have signaling. Signaling is basically all the call management stuff. So it's where you dial someone's phone number, that person gets located, their phone starts to ring, and then you get told that they've picked up the phone. Right? Like, that's actually a fairly large amount of stuff that needs to happen simply for a phone call to happen, just for the initial part to go down. So you've got like all the setup and location and tear down and whatever that goes on right here. Next you have like the media chunk, right? Obviously, since we're talking about multimedia over IP networks, media has to show up at some point. So this is where all the content streams are sent back and forth. The interesting thing is that these content streams are only unidirectional. So even though, sorry, we'll get to that in a minute. But right. So media is actually a huge part of voice over IP, and despite all that, there's actually only one protocol that we need to know about. The next one is PSTN integration. This is a great place for hacking. PSTN integration is basically the public switch telephone network, PSTN. What happens is VoIP on an IP network is very cool, but if you can't phone anyone off the IP network, it's kind of lame. So there needs to be ways of pairing all of your VoIP phone calls with all of your real-world landline and mobile phone calls. And that is done by PSTN integration software and boxes, right? So this is basically your telephone to internet traversal point. And what you'll find is, because this is where like the very, very expensive cool kit matches up with the wide open internet, this is where you can do all the cool stuff. This is where you can hop directly onto the PSTN and do pretty much whatever you want to do, such as make free phone calls, spoof phone calls, and so on. There's a lot of stuff that goes on in here. You've got location services, so you need to find a way of mapping real-world phone numbers to voice over IP phones, vice versa. You need to do media conversion, so you need to take the codecs that are used on the internet and convert them to codecs that are used in the PSTN. And you need to do signaling propagation, which we won't be looking at, but I believe there's a Frenchman. Is he here? Right. At other conferences, you can go and you can find out a huge amount about signaling propagation from the internet to the PSTN. Right. So, the protocol suites. Oh. I only figured out how to do animations on like a few of the slides. Okay, so we've got signaling. Now, the signaling suites are basically broken up into 2 different camps. In the first camp, you've got like the internet crunchies, like these happy-go-lucky hippie freaks who came out with the session initiation protocol, which is SIP. And you've got all the telco guys, which came out with the abomination that is H323. H323 is a huge, ugly binary protocol built on ASN1. If anyone's heard of ASN1, it's probably only in relation to the various bugs that have been found in it throughout the years. HTTP is built for a huge amount of redundancy, proper failover, and so on, and it's been used primarily by the vendors to create lock-in. So if you buy a Cisco Call Manager, you can't deploy it via phones. You have to deploy Cisco phones because their HTTP stacks are not interoperable. SIP, on the other hand, goes the other way. It operates with just about anything, including Netcat, Python scripts. It's wide open. It was basically designed around HTTP and email, so it should be very familiar when we get to it. All right. The media protocol, there's basically only this one, RTP. The real-time protocol is transported over UDP for speed and also for ease of spoofing attacks. Basically, RTP is it's the only game in town, right? So it's the only thing out there that you need to know about. It's very, very simple to parse. It's very simple to create. It's very old as well, and I don't think I've got any good slides in it. But there's some stuff such as basically the security of RTP is built on the randomness of only a few small fields. And what I've found in tests is that randomness is basically generated by the C library function rand, which basically means when you plot a graph, it goes like this. Right? It's very, very easily predictable. Maybe I'll show pictures in a minute. All right. The PSTN integration stuff. There's basically only two protocols which we'll be even talking about. First one is MGCP, which is the Media Gateway Control Protocol. Media gateways are one of the main points, obviously, between media traversal. So they take internet stuff in, internet media in on one side, and they have telephone trunks on the other, and they convert back and forth. They're a great place to attack because if they're directly exposed on the internet, MGCP as a protocol, in the RFC it's got a section on security, which consists of the following line. Security is assumed to be implemented in another protocol. With MGCP, you can basically take over trunk lines, you can drop whatever you want directly onto the PSTN, and what we'll find is that MGCP boxes are widely available, mostly from universities, although anyone who does any attacking will tell you that just about everything is widely available from universities. This is another one. I haven't talked about this one before. It's a new attack, basically Enum. Enum is a protocol for mapping our E164 phone numbers, which is like your normal phone number, onto voice over IP networks. The idea behind it is that if you have a VoIP-enabled phone and you're trying to phone someone else who has a VoIP-enabled phone, and both of you are using real phone numbers, rather than routing through the PSTN, you will look up in the Enum database to find out if there's a voice over IP route, which will give you a cheaper cost. The problem, of course, is that this means that everything that's not in the Enum database gets routed over the PSTN, and everything that is in the Enum database gets routed to the location stored in this database. And the databases are actually maintained by a bunch of volunteers. So there's 4 of them out there. They're all really, really easy to break into. They've got tons of like SQL injections and so on. And none of the big players, such as the banks, have figured out that they need to be registered in Enum in order for their customers to reach them via voice over IP. But we'll talk about that in a minute. Okay, a little bit more on session initiation protocol, because I did say that this talk was going to be on syphilis. Basically, SIP is an ASCII text protocol. It's designed by Internet Crunchies. It's the bastard child of HTTP and email. It's over a decade old. Like, the design began in 1995. The first release was at the end of 95, beginning of 96. For some reason, it's still considered an emerging protocol. So if you read any press release stuff on it, you'll almost always see like the new SIP or like using new emerging voice over IP protocols. What they're talking about is this decade-old piece of protocol. It's very commonly used for new deployments, and it's the most prevalent protocol on the internet. So if you're doing any VoIP scanning stuff, you're probably going to be looking for SIP. Right, SIP messages, they're basically either a request or a response message. They start out with a start line, which will have a method name and then the target